Okay, so in this video, we're going to talk about the ratio test, which is kind of related to the idea of absolute convergence, which I talked about in another video. So I'll just go straight into it. So the ratio test, you have some series. So what we're going to do is we're going to compute the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n. So we take the nth plus 1 term divided by the nth term, work this out, and then see what we get. So this is, just for your reference, this is a rho, not a p, although p and rho is a Greek letter. It looks very similar to a p, but it's a little more like curly-ish, I guess. So anyways, so we compute this, and so if rho is less than 1, the series converges absolutely. If rho is greater than 1 or infinite, then we say that the series diverges. And if rho equals 1, then the test is inconclusive and you have to think of something else to do. So let's go ahead and just apply this. So I've got this series here, and so I'm going to start by computing the nth plus 1 term. So notice how when I set this up, you want to be careful with how you do your nth plus 1 term. So n plus 1 needs to go in its own separate set of parentheses, so I am going to have parentheses within parentheses. There is a big difference, right, between this versus 3n plus 1. These are two totally separate things, so you just want to be careful with that, right? Okay, so I've got that over n plus 1 factorial, n plus 1 factorial. Now I know that I want to divide this by this term, but in dividing this, the equivalent would be to multiply by the reciprocal, so I'm just going to go ahead and multiply by the reciprocal. And so now we get to do some fun things with factorials. We have to kind of expand this out a little bit more. So specifically, this part here, so this turns into 3n plus 3 factorial. So this is what I need to recognize so that I can expand this. So I'm going to write out the first few terms now. I'm going to have 3n plus 3, 3n plus 2, 3n plus 1, and then 3n factorial. So that will just continue on from that point. And then down here, I'm going to write out n plus 1 times n factorial, and then n plus 1 times n factorial. So now I've got all that times this other term. So you can see why I expand everything out in the way that I did. It's strategic because now these 3n factorials cancel out, and these n factorials all cancel out. And so now I can go a step further with this. So let's make some space. So here's everything that I'm left with, and you'll notice, so this part right here, this I could factor out a 3 so that this just becomes n plus 1. And so that matters because then I'm going to cancel out one more factor of n plus 1. So then I'm left with 3 times 3n plus 2 times 3n plus 1, all of this over n plus 1. So now that I've computed this, I'm going to go ahead and take the limit as n approaches infinity. Now in this case, I technically don't need the absolute value. I'll put it there just to be precise. And then just to help me analyze this a little bit better, I'll go ahead and multiply these two things together. You don't have to multiply these together. You could tell what the answer is without it, but just to be very, very clear, this is going to be 3n squared, 9n, and 2. All of this over n plus 1. And so now, as n goes to infinity, you can see that the dominating term is on top. Like I said, you didn't have to multiply this out to be able to tell that, but you can tell this is increasing much faster now on top than on bottom. So the value of this will just be infinity. And so what does that mean? That means that the series diverges, right? Because if your rho equals infinity, then boom, the series diverges. Okay, cool. So now let's flip this and see what happens if I flip it. Okay, so very, very similar. So what I would recommend here is maybe for you just to take a moment to set this up. We did do some work, so you can kind of recycle some of this work. But just go ahead and try this on your own and see what conclusion you get and hit play when you're ready. Okay, so I'm going to have, let me change the color real quick. This will be n plus 1 factorial, n plus 1 factorial, and then 3n plus 1 factorial, And then we've got 3n factorial over n factorial, n factorial. It's very, very similar, right, in how we're going to cancel things out. So once again, I am going to just expand some of these things out. So this is 3n plus 3, 3n plus 2, 3n, let's see, 3n plus 2, 3n plus 1, and then 3n factorial. Okay, so we've got everything expanded and written out and all that good stuff. And so the n's cancel out, the 3n cancels out. So I'll make some space. So in this case now, here's what I'm left with. And so this 3n plus 1 will cancel out. So I'm just left with 3 here. So I'm going to have the limit as n approaches infinity of n plus 1 over, like, really the same stuff, right? So all of it really works the same. But now my dominating term is in the denominator, so this limit will end up equaling 0. And in this case, I dropped the absolute value just because this just stays positive, so I didn't need the absolute value. If you had it, that's totally fine. But now that this equals 0, so what does that mean? The series converges, right? So as long as it's less than 1, it converges. So it converges absolutely, and so therefore it converges on its own, right? So if it converges absolutely, then the series converges. Okay, cool. So that is it for this video. So if you found that helpful, I'd love it if you hit that like button. And I will talk to you guys next time. Bye!